So starting the lesson, already had to send a student to the corner. All right. Won't say who it is, but AW. What? All right. All right. So here we go. This is what you do without a calculator. Now, the first one, the sum, you already should have an answer, but you guys are all screwing around 6 hour. So I'm just going to go ahead and continue. And actually, adding these two and then doing the mod might not be hard, but actually, mod 7, knowing your times tables, maybe not doing that and actually trying to mod this. Now, I'm not going to write it like I wrote it yesterday. Yesterday, what I did is I said you could write this as 57 mod 7 plus 32 mod 7, and then mod each one. I'm just going to say to myself, I can mod 757, and I could mod 732 and get those two answers and then add them, because that's what I did yet. Right? How many times does 7 go into 57? 8. What's 8 times 7? 56. Again, I can't help you with your times tables. And then what does that mean the remainder is? 1. So that's why I can do that. And I'm liberally using the mod properties that says I can mod each separate part of the sum. And then 7 goes into 32 how many times? 4 times 7 is 28 with a remainder of what? 4. And then what you can do is add those two at the end because this is the sum of two numbers that you're modding. And that's it. If you went ahead and added these two numbers, you would get a number that has a remainder of 5 when you divide it by 7. So that's what it's saying. Timesing is actually, yes, this is a no calculator. So this would be on the no calculator part if there is one for the test or quiz that we have Thursday. So today's Tuesday, right? For a second, I thought today was Wednesday, which really ruined my day. How many times does 6 go into 37? 6 times 6 is 36 with the remainder of 1. And then fumble. 6 goes into 60, but that's too far. When you're dividing, my daughters have to say 6 goes into 59. What number almost to 59? All right, you got to remember grade school. So actually 6 goes into what? Not 60. What's the next one before that? 54. And then what's the remainder then? 5 away. And then for multiplication, you multiply those. So weirdly enough, you get 5 for a final answer for both of these. It's random. Okay, now I do want you to take a minute. I'd like to be, this is like what Common Core, let the students get their answers. And then share. Take a moment to try to do 7 because you haven't done squat. All the talking before. 7 is no calculator. Dun dun dun. That are like on a island of you gotta come with us on the boat in the math boat where we know how to do stuff. All right. So 3 to the 4th, I'm just going to get to it, is actually equal to 3 squared is 9. 3 squared is 9. 9 times 9 is 81. Did anyone just figure out what I just did there? 3 squared is 9. This is 3 squared squared. Let it go. Okay, so 9 times 9 is 81. I cannot help you if you cannot figure out dividing by 5 and 10. 5 goes into numbers evenly that end in 0 or 5. So what I know is 81 mod 5 is 1. 5 goes into 80 evenly with the remainder of 1. So this is 3 to the 4th. Now here's where you can argue. And sometimes this is a little bit of a challenge. It doesn't have to happen right away. Oh boy, I almost tripped on this cord. Okay, it doesn't have to happen right away. Sometimes it might take till 3 to the 7th. And then we're probably talking about a calculator. You know, trying to find out where do we get a remainder of 1. I think on our worksheet there is one that is, you need a calculator to figure out where you get the mod of whatever equals 1. Not this one. Okay, so now here's the next thing. You could argue. But, what we need to find is 4 times what comes close to 98. Now that might require a calculator. What'd you guys get? 3 to the 4th raised to what power? What's this next number? What'd you get? Or did you even do it? You kind of need to do it so you know what's left over. Like 4 goes into what? What's closest to 298 that 4 goes into? This is not mod math. I'm just trying to find a... Well, I was looking for 296 on that next question. So 4 times 74, and then again, this might be the calculator part. I got to get 4 times something that's as close as possible to 298 because of power rules. This is not mod mathing. This is actually using your Math 2, Math 3 rules to use my exponent rules. Remember I told you in this class, you're going to add, subtract, multiply, and divide, and then you may deal with some exponents. Well, here's the exponents. And that's about it. The math is no more than that. And then what's left over? Well, 4 times 74 is 3 to the 296. That's what I was trying to get at. You know, that 4 times 74 is 296. You multiply exponents when you have a power raised to a power. So what does that mean is left over? 3 squared. And then we're going to mod 5 that. And then what I could do is I could, remember the product? Like this one, of course, I fast-tracked it. I could do 37 mod 6 times 59 mod 6, but I just did the fast work there, and I'm going to do the fast work here. I could mod 5 this, and then I could mod 5 this. Well, the way to mod 5 the first one is to mod 5 the interior of those parentheses. What's 3 to the 4th mod 5? What did we just find out? It's equal to what? 1. And then all you have to do is take 1 to the 74th power, which is what? 1. It's not 74, whoever said that. All right? And then 3 squared mod 5 is left over. What's 9 mod 5? What's the final answer? 4. We'll put it as 4 mod 5 or just 4. I really don't like how they do that. I should say 9 mod 5 equals 4 mod 5. Sometimes I write 9 mod 5 equals 4, and then they just stop. Okay, so I made a management decision, which your homework is less. I heard the homework was a little bit lengthy. Of course, I don't know. Today's short, and actually I took one off because tomorrow, the beginning of class, we'll do one more in your homework after I do a set of notes and then go from there. Okay, so today we're pretending we have schemes for ID numbers. And today's schemes are all mod schemes. So notice what it says in red there. All schemes noted as mod number scheme, as a mod number scheme, means the check digit is equal to mod of all the previous digits. For instance, example 1, I probably could have wrote a little bit more clear, but really what it says is this is a 5-digit ID number where they give you the first 4. And the check digit comes from mod 7ing the previous 4 digits. And whatever you get for that is the check digit. And every one of these is going to work just like that. What I decided to do tomorrow was there's something called Euro banknotes, and I'm just talking while you write this down. Euro banknotes, actually, it's almost as old as you, I feel like. I feel like Europe went to the Euro banknote where Britain, France, they all came up with a common currency. And that is relatively new. There used to be a British pound. There still is? They don't use the euro? They changed it back? Maybe they left. Okay. Okay, hold on. All right. No more about Brexit. Brexit has nothing to do with what I was talking about. Nothing. So maybe I found out I'm wrong that the pound never left. I don't know. I don't really watch a lot about currencies. Maybe Britain didn't use, but the rest of Europe got a common currency. Okay, and anyway, that Euro banknote has a check digit scheme according to our book, according to 2003-4 when the book was written. And I found it interesting, but it's a little different than these schemes. I just don't want to confuse you. So back to this. All right. Do you have a rule for dividing by 7? Yes or no? A trick. Is there a trick? No, no trick. So what you physically have to do is divide 4,329. You have to divide that by 7. And then I hope you're not robots and then, oh, when I do this, I have to do this. I hope you understand that I've been trying to tell you why this is. This means when you take 4329 and divide it by 7, this decimal right here equals, this is 618 and blank over 7. That's what this decimal represents. Again, grade school. I told you when my daughter has to divide numbers, she's going to learn A, to put the remainder over the divisor. Then the next thing she's going to learn is put a point, and then put a bunch of zeros after that point and start learning what a decimal means. And the decimal is equal to writing it as a mixed number. So what do? I got to lop off this 618. And then I got to take this leftover decimal and multiply it by 7 to figure out what this numerator of this mixed number is. Hence, that is the what? Starts with an R and ends with remainder because I don't have the time. 3 is the remainder. And that's what mod math is. Hold on. I got too many icons down there. Here we go. All right, here we go. All right, now look. Shh. Why is this no calculator? Because of the 9. There's a special divisibility rule because of how weird numbers work. Sometimes there are some weird things that you can do different stuff with numbers. And again, this is the same idea. This is a 5-digit scheme. I'm sorry, this is a 5-digit ID number, and we're looking for that last digit. So whenever they say it's a mod whatever scheme, the check digit is when you mod the previous digits. And because this is divisible by 9, I'm making you use the divisibility rule by 9. We're going to restate this over and over again. 5 plus 6 is 8. 8 plus 6 is 14. This is 22. So what is 22 mod 9? 9 goes into 18, 19, 20, 21, 22. This equals 4 mod 9. Now, listen. 4 is the answer, and you're done. But I just want you to understand, if we took our calculator and divided 5,368 and divided it by 9, I would get some number and 4 over 9 as the mixed number when we did what we did in the last question. So the magic of dividing by 9 also works for the remainder of that particular number. Okay? So if we were going to use a calculator and go through this process, you would get the same thing. You would get 4 as the remainder. So that's why with no calculator, I'm forcing you to use that divisibility rule, blah, blah. The scheme for a Euro bank number is kind of similar to this one. I believe a Euro banknote has 16 digits long. You know how big that number is if you put it on your calculator? It'd be huge. The Euro bank scheme does use mod 9 as its scheme, but it does something a little different than this one. So I just want you to be aware of that. And look at this. This number right here is actually, I'll do this in colors as you're writing it down, 2,995,000, blah, 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 blah. Big number, right? So it'd be a pain to type it on your calculator and divide by 9 and then figure out the decimal through example 1. So that's why this is nice. This is a mod 9 scheme. And I'll tell you why what I'm going to do next works. What I'm going to do next is called casting out the 9s. So you can only do this with a mod 9 and actually a mod what? What else has a special 3? I couldn't even spit it out. So what I'll get on the quiz on Thursday is people doing this on mod 7s or mod 8s. And it doesn't work because there's no special divisibility rule for those. Okay? So now, why would I cast out the 9s? Well, I'll tell you why. Because For instance, you know, when I start doing this, 2 plus 9, right? And this is going to be long, isn't it? Don't these two 9s, if I subtract them out, wouldn't that still be like I'd have a remainder of 2 at this point, correct? And it wouldn't change anything? You know what I'm saying? So when I'm going to do the sum rule for dividing by 9, I can reduce that sum because that's already a multiple of 9. And I can get rid of that and not even worry about adding, and get rid of that and get rid of that. And not worry about that. And actually, I'll do it in full after this and show you how it does not matter. But wait, there's more. Are there any other couple of numbers that actually, when added together, obviously equal 9? Yes. 7 and 2, and I'm going to pick a different color for that. 7 plus 2 is 9. What else? 8 plus 1, I'll get a different color for that. And I'll show you why this works. What's left over? 5. Guess what the answer is? 5. So through casting out the 9s, we actually got a quicker sum. And remember, whatever the sum leaves as a remainder, so will the actual number, 2,995,000 blah. When it's divided by 9, it will have a remainder of 5, doing it the calculator way. Now, why did this work? This actual sum is 9, 18, 27, 36, 45, 54 plus 5. The full sum is 59. Guess what the remainder is? 59 mod 9, I mean. It is 5. 9 goes into 54, and with a remainder of 5 anyway. So casting out the 9s just reduced the sum and made the remainder of the internet this. What I should have done next, but I'm going to make a little change. We'll do this tomorrow. It's not a mod 9 scheme like how all the mod things, so I don't want to confuse you. There's just one minor difference, and I think I want to separate it tomorrow. So the beginning of tomorrow, we'll do those two examples, and I'll ask you to do number, I think, 33 in your homework. If you wanted to read it on your own, there is a difference. It's very minor, but I can cover that tomorrow. So let's go to this one. And I think I only have 2 more. I think compared to yesterday, this is not too bad. Stop. Okay. All right. That's me. My fault. I don't want to blame the computer on this one. So determine the missing digit. Okay, so it's not really clear. I should be more clear. This is a 1, 2, 3, 4. This is a 5-digit code. 7, 3, missing 1, 1. That is the check digit because it's a mod 9 scheme. So this came from, now I want you to just be ready for the homework. This came from 73D31. I mod 9 that, and I end up getting 1. And I could just write 1, or I'm going to write 1 mod 9, because mathematically I really feel like that's the way these should be written, because the check digit is given. Now thank the maker, if there is one, that this is a mod 9 scheme. Because if this is not a mod 9 scheme, if it was a mod 7 scheme, it would be really tough to find that digit in the middle. You basically have to do trial and error, and it may not even work. But with it being a mod 9 scheme, it definitely will. Because what's the divisibility rule of 9? What can I do with the digits? And by the way, there's 7,000. Well, we're not going to cast out the 9s in this case. We're going to go ahead and go back to that adding. And then just figure it out. And then I'm going to keep going. I am going to mod 9 this sum. And by the way, this is supposed to equal, let's just put 1, not 1 mod 9. We know what we have to have left over. 7 plus 3 is 10, 11. And now you just got to think, what does D3 have to be so that when I mod 9 this, I have a number that has a remainder of 1? Why 8? What's 8 plus 11, everybody? 19. And 9 goes into what? 18 with a remainder of what? 1. So D3 has to equal 8. This is not algebra. I could algebraize this and add more variables. But really what we just have to do is think. All right? And actually come up with the number. So this digit would have to be, let's just change the color. Ooh, this is my new favorite color lately. 8. Do you see what I deal with? Do you see this? Are you all right? How you feeling about mods? Okay. Now, here we go. Same old, same old. Okay, so now, you know what? 1, 2, 3, 4, 5, 6. Shh! Okay, yes, I am. I am. Okay, it's the only difference with this one. This is a 6-digit number. 4, 5, 3, blank. 4, 7. We're filling into blank. By the way, in all mod schemes, this is the check digits. Whenever they say a mod scheme. The Euro banknote's different. That's why I don't want to confuse you today. Very short assignment on what we have for this. So it's the same old. It's a mod 9, too, because it's under the same directions. And if it wasn't a mod 9, it would be really hard. You'd have to do trial and error. And it'd be a pain. Fumble. And it may not even work. Okay. Yes, I am. Okay, now. 4. Hey! Can we cast out the 9s? What's 5 plus 4? Yeah, I mean, really, we could cast that out if you wanted and just do 3 plus 4. Okay, so what's 3 plus 4? What's 3 plus 4? 7. 7 plus D4 mod 9. Oh, it feels refreshing in here now. Should equal 7 mod 9. You had the question, sir, earlier. What does D4 have to be? 0. Remember you asked? Because I don't want to add anything to the 7. 7 mod 9 equals 7 mod 9. So I must add 0 to this. So digit number 4 must be a 0. And I will put that in there in this position. Okay, so I casted out those 9s. And somebody goes, why'd you do that this one? Fine, I'll undo it. What's 9 plus 3 plus 4? 9, 12, 16, right? So if I didn't cast out that 9, did it change anything? No, all I did is take out a multiple of 9. So what's the remainder when I 16 mod 9? It's still 7. So I still need D4 to be 0 here. So again, that's what the casting of the 9s, it makes you add less things. If you see a 9 in a mod 9 scheme, you can cast it out when you're doing the sum, dividing the sum thing. But anyway, that's the ID number.